piece of paper. I don't even have my binder or my computer.
I knew I should have stayed home.
Lucky balloon animal.
How'd that go?
Oh, good. Yes. What rest of these?
And basically go ahead and start working on those. I know we did it the other day. I think the same numbers. I'm not sure. I mean, we can add 2 more numbers or we can change them. It's up to you. But I want to just go over what we did the other day because I can't remember. I think I just had drawn the normal curve and I can't remember. So I'm just going to go over it again. And the mean, you're going to add up all your numbers and divide by 10. And then the median is going to be the middle. So in that case, it's going to be probably these two. 4 up and 4 down. So that's going to be the median. I'll highlight those. And we take the average.
15.4.
Do y'all have a question?
I was just saying the first answer is 15.4.
What, she cannot see? It might help if you sit at the front of the room instead of the back of the room,
Nobody
Miss
even
Simmons.
said nothing about. Nobody even said nothing about that.
Okay. And the mode, I care less about the mode, but it looks like 8,9.
You have a work email.
Range is equal to the highest minus the lowest.
You have a work
And
email.
mid-range is equal to the highest plus the lowest divided by 2. Oops, I forgot to hit equals. I can't type today. There.
Is that for us?
Then the variance and the standard deviation. Now, for the variance, we got to remember the formula for the variance. The formula for the variance is the summation of x minus x bar, quantity squared, over n minus 1. So go ahead and do what you need to do to get those numbers. You're going to need x minus x bar first. Sorry about that.
I'm gonna cry.
Why are you going to cry?
Because it's a stressful day.
Why does it say Oconee Hall got disconnected? How did that happen? Miss Simmons, what did you do to knock them off?
I didn't do nothing. I'm innocent.
It says they're offline.
They just said, forget it, and they going home.
Yeah. I guess I should cancel class, shouldn't I?
Yes.
I don't know why it's not. Where is the Hold on a second. Keep working. Keep doing the x minus x bar. You need to make a column right here called x minus x bar. X minus x bar. This is x. And the mean is x bar. So you got to take each one away. And then you got to square x minus x bar.
At this point, yes.
What'd you say, Miss Simmons?
I was talking to Mr. King, so.
Well, if you're going to talk while I'm talking, at least tell me what you're talking about.
I said I'm hungry.
Well, go get something to eat.
I leave your class almost every time.
Well,
I'm trying to
whose
make
fault
it
is
through.
that?
Mine. That's why I'm trying to be better. Dang.
Oh, well, I appreciate that.
I mean, if
Okay,
I
let
knew
me
that
try
I
with
could
Coney
leave,
again.
if I knew that I could leave and you wouldn't drop me, I would never come back.
I don't drop anybody. You didn't listen the first week of class.
I know, but you say that, but then I'm gonna have them in my ear calling me talking about some absences, man.
Well, that's because somebody's trying to justify their job over in the library. That's all that is. Anyway.
All right.
What?
Thank you.
Thank you, sir.
You're welcome.
What happened? Did y'all turn it off?
No, it just reset in the middle of you talking.
The screen went black.
I don't
Yeah,
know.
that happened to me. That happened to me Tuesday. Just all of a
And then
sudden,
like something
it
about
said,
a low balance. I don't know.
We have a balance of $0.
I think it's something to do with the Russians. All right,
Probably.
8 minus 15,
I don't know how
F4,
to turn Windows to.
copy down. Got to make sure when you're using the spreadsheet. And now I'm going to square that column. Copy that down.
A women's clothes. Not really. Well, some of them.
All right, now what do you do to all of those?
You square.
We already squared them.
Well, I wasn't here for that.
What do you do? What does that big funky E mean?
The atom.
Add them all up. And 520 is the numerator. I'm just going to go over here and 520.4 divided by, how many numbers do we have? 10? What's 10 minus 1?
9.
9? And somebody do that for me. Well, I'll do it on the calculator, on the spreadsheet. So the variance
I'm just really lost.
is going to be equal to this number divided by 9. And then what's the relationship standard deviation to the variance?
He ain't say nothing. That's why I'm like,
0.5 power, square root.
I'm about to go. I can't do this.
All right, who's got a question?
I'm gonna.
So I covered the material so well, y'all don't have a question.
Yes. We need to go home and study at home in peace and quiet.
And take a nap at home.
Yeah.
No comment.
I'm
All right, now
exhausted.
let's do it on the calculator. So what do you hit first? You hit stat.
This class is just too long. How can a 55
Make sure
minute
class is too long. It's only an hour. It's not
What
even
I'm
an
saying is
hour.
like,
It's 50 minutes.
listen. By the time it hits 1 o'clock, it's done. You know what I mean? Because like by 1
Anyway.
o'clock by 1 o'clock you've already said what you like. What you know, like the teacher.
Where's your
And we're just
calculator?
over it.
Where's your calculator, Miss Simmons?
Right there plugged up.
All right, anyway, get your calculators out. Mr. King, do you have a calculator? Y'all need to get your calculators out. Oconee, do y'all have calculators up there?
My calculator's charging right now.
We need to get them out, or unless y'all want to just do it by hand.
I can
Edit,
do it.
and then type in your numbers. 8, 9, 12, 16, 18, 19, 26, and 29.
What do we hit? Sin?
Now you hit Stat, Calculate, First Variable Statistic. It automatically goes to L1
I have a fancy calculator.
and Calculate.
Oh, here it is. I found it. Wait.
Now, look at X bar. X bar is 15.4. And what is the standard deviation? SX. And I'm going to put SX right here so you'll know what to look at on the calculator. And that's how you do it on the calculator. Question.
Old.
All right, now, let's change the question. Let's see, we got 1, 2, 3, 4. Let's go with ages. 18, 19, 22, 26, 28, 29, 36, and 39. All right, do it. Do it with those numbers. 18, 19, 22, 26, 28, 29, 36, and 39.
My glasses broke, so I really can't even see. Sorry. But I'm with you in heart, you know.
Thank you. So go ahead and punch those in. Either do it with your calculator or do it with your Excel spreadsheet. Or if you don't have either of those, write it down in your notebook and do the 3 columns. And do the best you can without having a calculator. You might have a calculator on your phone that you can use. And you can also, if you, I don't know what kind of phone you have, but Android, you can go to Wabbit EMU. See up here on the calculator? See that in the top left-hand corner? Wabbit EMU. And you can download a TI-84 Plus or TI-83 or TI-85 or TI-89. You can download those on your phone. But I don't know about no iPhone because iPhones, they charge you for everything. So I don't know if you do it with an iPhone.
So am my dad.
So go to Wabbit EMU and you can download your calculator.
Why would you call it Wabbit?
What?
Nothing. It just sounds like you're saying it wrong.
No, it's WABBIT.
I can read, Hubert.
What?
Whoa. Whoa. She took my spot. We love a sassy queen.
I didn't hear you. What'd you say?
I said I can read. It don't sound right. Wabbit.
I wasn't talking to you. I was talking to the whole class.
Exactly. And I'm not in the class. So.
Ooh.
Why are y'all so hostile today?
Because we're tired.
I want to
Well,
go
I'm here.
home. I'm hungry.
It's nice to meet both of you.
I'm blind. What
Well,
more can be wrong?
That's what the front of the room is for.
It don't matter how close I am. I'm blind.
Okay.
I have astigmatism, I know that.
Okay, so y'all, I don't know if you, I'll talk to Mr. Miles and Mr. King because everybody else is kind of mad at me today. So,
I'm right
Mr.
here.
Miles and Mr. King, do y'all have any questions on
Mr.
that?
Miles is probably drunk.
I do not.
No, sir.
Mr. King, okay, well that's how you do basically 12.3 and 12.4. Okay, so now we can move to 11.1. So let's move over to 11.1. And, well, let's see what else they show you on this. Yeah, I've already done all that. This is all, find the standard deviation, standard deviation. Yeah, they're doing the same thing, standard deviation, so that's it. Now, let me go to 11.1. Somewhere on here, I'll go to 11.1. And this is probability. So you might want to make a note on this one. And probability is, and I'm going to give you a Hubertism definition, and that is basically assigning a number to a prediction. Okay, that's what probability is. So I'm going to take the handy dandy calculator and I'm going to get down. Probability is used in many areas, mathematical, blah, blah, blah.
I can't do this.
Experiment. So I'm going to insert I'm just going to insert a white screen here.
You can leave.
There we go. And I want it to be, I'm going to delete that. Well, it won't let me delete it. Oh, forget it. I'll just go to the whiteboard. Probability is the assigning of a number to a prediction based on three things. Assigning a number between 0 and 1 to a prediction based on experience, logic, or data. Example. You get behind somebody on a two-lane highway that you can't pass on, and you get to the end of that two-lane highway, and you either turn right or left. And you're going to turn left, but the person in front of you that's going 30 miles an hour hasn't turned on their blinker yet. You start to get up to the red light, and you say to yourself, that person's going to turn left. And as soon as you say that to yourself, what happens?
They turn.
I'm asking y'all to interact
They
with
turn left.
No, they do not turn left. They turn on their blinker to turn left. Okay? What have you just done?
Prediction.
You just basically predicted, you didn't predict the future because nobody can do that. Okay? If anybody ever tells you that they can predict the future, all you got to do is ask them one question. What is it? What are the lottery numbers? That's all you have to do. They say, well, that ain't what, then you're full of stuff. Okay? If they can't give you the lottery numbers, then they are full of BS, because that's predicting the future. Okay? If I say, Mr. King, when you walk out of that door at Easley campus, you're going to fall down on a slick spot of water. And it happens, that's predicting the future. Y'all ever seen
No, it's
Groundhog
not.
Day?
That could just be a coincidence.
Y'all ever seen Groundhog Day?
No.
God. It's a freaking great movie. Y'all never seen Groundhog Day?
No.
That's really sad. Okay, well, anyway, on Groundhog Day, he plays the same, he does the same day over and over and over. And eventually he memorizes what happens during a 24-hour period, and he sits there and he says, this is going to happen, this is going to happen, this is going to happen. Yes, that's predicting the future, even though he's replaying the same thing over and over and over. So the point is, nobody can predict the future. But what we can do is we can take our experiences, we can take logic, and we can take data from
You can make
stats,
it inference.
and we can actually predict what's going to happen with a number between 0 and 1. And the number between 0 and 1 is basically a scale.
Oh my child.
0 means very unlikely. I don't know how to spell likely. And this means likely. And of course, in the middle means halfway. So whenever you're talking about probability, you need to address it in form of a decimal. Okay, you need to write that down because it's very important. A lot of people say percent, and that's not it. Percent means chance. Decimal means probability. So when you're talking about calculations, everything is going to revolve just like area under a curve or whatever. Everything is going to basically equal 0 to 1. Okay? Now that's what probability is in a nutshell. Okay? It's nothing. I'll give you a definition that's going to be all mathematical, but that's basically what probability is. Assigning a number to a prediction based on those three things. Okay? And I'm going to go through this. I don't think y'all need to. Y'all can look this up on Google if y'all want to. Just look up the history of mathematics and statistics. Okay? An experiment. Write this down. These three things right here are very important. Can anybody tell me the difference between an experiment and an observation?
An observation is just. Go ahead.
Go ahead. An observation
Test
is just what?
experiment. You test an experiment, you don't test an observation.
Good job. Observation is basically what we talk about in statistics. An observation is when you just look at people, or you look at an experiment. An experiment is when you actually do something in the experiment, whether you control it or you test it. Okay? Please don't make that annoying noise. Experiment is when you actually interject into the observation. You either do a placebo effect, you use electrolysis, you use, put cheese in a rat maze or a mouse maze, whatever you want to call it. You're manipulating the observation, and that's when it becomes an experiment. Possible outcomes of an experiment are called outcomes. Possible results are called outcomes. If somebody is pregnant, what is the outcome?
A baby.
They're going to have a baby. Okay, that's an outcome.
Ew. Chill.
Okay? An event is a sub-collection of outcomes. Okay? Let's say if you work on the labor and delivery and the full moon is out and you have 7 women go into labor at the same time, that is an event. Okay? So you need to know the differences between those three things. an experiment, an outcome, and an event.
My arms got pretty thin.
That's very nice.
Empirical probability is the relative frequency of an occurrence in an event and is determined by actual observations of an experiment. Whereas the theoretical is based on mathematics. Mr. Miles, Mr. Hudson, sorry. You there?
Nope.
Yes, he's not. Mr. King, you there?
Yes. Yes.
What's the probability of pulling a king out of a deck of cards?
1 in 52.
Okay, well, 4 out of 52, but you're thinking correctly. All right. Where's your deck of cards? You got a deck of cards with you?
No, I don't keep a deck of cards.
Well, how did you know that, Mr. King?
I play cards.
Okay, you've seen cards before, right?
Yes.
Okay. You base that theoretical probability based on the mathematics of a deck of cards, right? But if I gave each one of you a deck of cards and told you to shuffle it 10 times, pick, in other words, shuffle, pick, and put the card back in, write it down, put the card back in. If you did that 10 times, you might come up with 0 kings. You may come up with 8 kings. You may come up with 4 kings. The whole point is the empirical probability is based on the actual event of shuffling the cards and actually picking a card, putting it back in, and shuffling it 10, 15 times. Now, what I usually do here is I usually give out my cards and my die, and class usually, but I can't do that because y'all don't have a deck of cards, and probably y'all wouldn't do it because y'all hate this class. But anyway, to make a long story short, the number between the empirical rule and the theoretical rule, they're not equal. Let's say you take a deck of cards and you shuffle it and you pick an ace. And then you shuffle it and you pick a 10. And then you shuffle it and you pick a 3. And then you shuffle it and you pick a king. And then you shuffle it and you pick a queen. And then you shuffle it and pick a 2. You shuffle it and pick a 4. You shuffle it and pick a 6. You shuffle it and pick a 7. Let's see, it's 8. And then you shuffle it and pick another ace. The probability, somebody take your probability, your theoretical probability. You said 4 out of 52. Somebody take your calculator and calculate 1 out of 13. What do you get? What do you get?
0.0769238.
0.08. Thank you. Now, somebody, how many kings did we get out of 10 draws right here? 1 out of 10, which is equal to 0.1. These two are not equal. Now, a lot of people say, well, Hubert, 0.8 is real. 0.08 is really, no, I'm asking you, are they equal? No. Now, why am I making that point? Because in order to get the probabilities to equal, you have to depend on what's called the large number rule or the rule of large numbers. Okay? Now, it's very important that you understand this because some of you who really care about what I'm talking about, you actually need it later on because it's part of CYA. Do you know what CYA means?
Nope.
Nobody in here has ever heard of CYA. Well, that's sad. Cover your
Ass.
Thank you. You have heard it. I appreciate you interacting with me when I asked the question to begin with. Cover your backside. Okay? Cover your backside. What does that mean? That means whenever you do a job, you need to do it what?
Carefully.
You need to do it carefully and you need to do it right. Okay? So, the law of large numbers basically says this. The more data, the better. So that would mean LAD does not play into this. Okay? Let me give you an example. If I was a quality assurance director executive with Michelin, okay, and let's say that I work up there at the Crystal Palace up there between Greenville and Spartanburg on 85, okay? It's about, what, 7 or 8 story building. It looks like a Crystal Palace. And I get paid $125,000 a year, and my job is to worry about the defects in the Greenville, Sandy Springs, and Anderson plants. Okay? And that's my only job. And I report every year. I do a report, and every year I give them a number. And I say that blank percent of our production in the Southeast is defective. And then they take that number and they project for the next year budget. They say for the next year budget, we got so much for defective tires. And that's my job. So I get, it's about June or July, and I've got to get these numbers up, and I'm in a hurry, and I got things going on at home, and I've got all kinds. So I just go out and I tell the directors at each plant, the Sandy Springs plant, to tell them to pull 500 tires. 500 times 500 times 500 is 1,500. Okay? And tell me how many are defective. And then you come out and you say 12% are defective. And you present this at the report. You say, okay, and the only people at the report are the CEOs. The CFO, the CEO, and the board, and all the people that pay your paycheck. Okay? And you say that 12% are defective. And they say, okay, they crunch the numbers, and they say that's $1.2 million that we need to put aside next year for defective what? Defective tires. Because you pull 1,500 tires. You pull 500 out of the Sandy Springs plant. You pulled, and you checked them to see if they were defective, and 12% came out to be defective. Next year rolls around, and the defective tire, the actual tire defective tire count was 28%. What are you?
Another zero. 15,000.
What happens to you?
Back himself from size.
What is it, Oconee?
Nothing.
You know,
You did your math wrong.
Yeah.
what math?
You
It's
said
not 1,500.
it's 500 times 500 times 500, right?
No, there's 3 different plants.
Well, it's 1,500. 3 times 500.
Or from somewhere else. It's not 500 times 500. It's 500 times 3.
Okay, that's what I was confused about.
Oh, I was just making it up, okay? Now, all
For
right.
real.
Does everybody understand where we at? 12%, I said 12% are going to be defective next year. They put in the budget $1.2 million for defective tires. Next year rolls around, and the actual defective account, or the actual defective count, is 28%, which throws it into 3.8 million. What are you?
Screwed.
How would you say that in real world terms? Starts with a F.
Fired.
Fired. You are fired.
That's something.
Why?
Yeah.
Because you
Because
messed up.
what's your only job?
Eternity.
Your
To
only
count
job
tires.
is to report the defective tires. That's your only job. And they pay you $125,000. And just because you suffered from lazy attitude disorder, you projected a wrong number. Your butt's fired. So what should he have pulled? He or she, instead of 1,500, should have pulled maybe 5,000 tires, depending on how much Michelin puts out. Which, how much does Michelin put out? A buttload of tires. Okay? So 1,500 would not have been a drop in the bucket. Okay? The law of large numbers basically says, as you increase your numbers, the empirical or the physical probability approaches the theoretical probability. Meaning that if you, instead of doing 10 draws on a deck of cards, you do 100 or 1,000. You're going to get closer and closer to that 0.08. Now, the three things that you need to know here, you need to know the empirical rule. Let me get there. Hold on. You need to know well, I can't get there right now because everything's up here. You need to know the empirical probability, you need to know the theoretical probability, and you need to know the rule of large numbers. Okay? And the rule of large numbers basically says that the more experiments you try, or the more events that you try, the closer the two probabilities are to match each other. It also says that if you suffer from lazy disorder and you don't do your job, you're going to get your butt fired. Okay? So, with that being said, what is probability? Well, that is the way you write the probability of an event. You put a big P, and then you put parentheses with whatever the event is, or the initial of the event. This is an event, so the probability event. The number of times something has occurred over the number of times it has been tried. Okay, so I don't know how you want to write that, but that's basically what it is. All right?
Over number.
The number of times something has occurred over the number of times something is what? Tried.
All right.
Okay? And I know I got 10 minutes for some of y'all that's fixing to go into convulsions. If 100 tosses of a fair coin, 44 land on heads, what is the probability of heads?
44 over 100.
Good job. And, well, now whatever. 44 over 100 is the probability of heads. Now, I want you to tell me what the probability of tails is. Probability of tails is the complement. Write that down. Complement. Probability of heads is equal to 44 over 100. Therefore, the probability of, I'm going to write it in black, the probability of tails, what's the complement of 44 to 100? 56 over 100. This is what we call the complement. The complement is what makes up the whole. What is the whole? The whole is 100 tries. How many times did we hit heads?
44.
So how many times did we hit tails?
56.
Because that's the only alternative to tails, to heads. You can't flip a coin and get heads, tails, and biscuits. Okay? You only get two things. You only get heads or you get tails. And if you got 44 heads, then that means the alternative to that is 56 tails. So that's a complement. Okay? And we'll get to that eventually, probably when y'all come back. Okay? All right, y'all have a good day and a good weekend, and I will see y'all Monday.
Maybe not. I'm just kidding. I'm not.